Okay, so now let's look at a couple of sequence and series problems. Should be very straightforward. So this one is write the first four elements of the sequence. So when n equals 1, so you're going to have 1 plus 1 over 3 minus 1 when equals 2. So it's 2 plus 1 over 3 times 2 minus 1. When n equals 3, so you're going to have 3 plus 1 over 9 minus 1 when n equals 4. So it's 4 plus 1 over 12, right, minus 1. So here you're going to have it's 2. So it's 3 over 5, right? 4 over 8, so it's 1 over 2. 5 over 11. So the answer for this one, made a mistake. Silly mistake. So 2 over 2 should be 1. So it's 1, 3, 5, half, 5. So the answer is going to be B. Okay. Number 6. A recursion formula and the initial terms of a sequence are given. Write out the first 5 terms of the sequence. Okay. So yeah, this is also simple. A1 is 4, so A2 basically it's so it's number 5. Okay, so number 6. So A2 is going to be when n equals 1, right? So it's negative 1 squared over A1. Since A1 is 4, so A2 is going to be positive 4 over 1, 1 over 4, excuse me. Okay. So A3 is going to be negative 1 cubed over A2. So it's going to be negative 1 over 1/4. So it's going to be negative 4, right? And then of course A4 is negative 1 to the power 4 over A3. So you can see it's going to be negative 1 over 4. And then of course A5 it's negative 1 to the power 5, 4. So what we're going to have, excuse me, so negative 1 over negative 1/4. It turns out it becomes into 4. So the answer, let's check. We have it's A1 is 4, A2 is 1/4, negative 4, negative quarter 4. So the answer is B. So this is super simple. Okay, that's number 6. So now let's look at a couple of other different questions. The number 7 here is said, okay, find the limit of the sequence if it converges, otherwise indicate diverges. Okay, so by talking whether a sequence converge or not, that means if you take the limit of this an, that limit exists. Okay, so for here you see an equals this is number 7, equals 6 plus 4n over 5 plus 9n, right? So if we take the limit, let n goes to infinity. So noticing that this limit is easy to evaluate, so this is 4 over 9, so hence this sequence converges to here. So this is simple. Okay. Number 8. So we have negative 1 to the power of n times 1 minus 3 over n here. As n goes to infinity, if we only look at this inside of the parentheses, it goes to 1. But this negative 1 to the power of n, it will keep alternating, right? So either it's negative 1 or positive 1, negative 1, positive 1, negative 1, positive 1. And this alternating will never stop. So hence, this sequence diverges. Okay, that's easy. Same logic for number 9. So we have an equals 6 plus minus 1 to the power of n over 6. So assume, you have n is let's say an even number. So you're going to have 6 plus 1 over 6, right? However, if n is an odd number, so you're going to have 6 minus 1 over 6. So again, this is an alternating term. It will never stop to doing this alternating. Positive 1, negative 1, positive, negative 1. So our an is also diverged. It's kind of like a bouncing back between 7 over 6 and 5 over 6, right? So it's keep bouncing back and forth and never stop. So hence, diverge. Easy. Let's also move on to, let's see, number 10. Number 10 is said that, so it's a final formula for the nth partial sum of the series, okay? And I use it to find the series sum if the series converges. So for here, a sequence, it's a list of numbers with order. But a series or infinite series, it's a summation of a given sequence. Okay, so in other words, you see a series is the summation of a sequence. So the nth partial sum here, so this is number 10, right? So we denote it as Sn. It is defined as the summation n from 1, maybe key from 1 to n of a k. Okay, so in other words, it's a summation of a1 plus a2 plus a3 plus a4 up to an here. Okay, so that's the summation here. So you can see that this is our a1, a2, a3 up to this is an. So basically what we're looking for is, this is the nth partial sum. Okay, this is the nth partial sum. So what we can do? Well, for this problem, let's see if I can get a clean part. Okay, so we can use this. You see it's 9 over 1 times 2 plus 9 over 2 times 3 plus 9 over 3 times 4 plus plus 9 over n plus 1, right? Okay, we're looking for this. That's our Sn, nth partial sum. So first of all, do you realize that on each term, 9 is a common factor, so we can factor them out, right? Okay, so that's the first step. Second is observing that I'm going to have this 1 over n plus 1, right? Let n starting from 1 to n here. So if we only specify this an here, which is right here, or part of this an component, a trick or a thing is 1 over n times n plus 1 can be split. This is kind of like using the partial fraction decomposition technique into 1 over n minus 1 over n plus 1. Okay, so this is a super useful format. So I hope you can remember this, because if we rewrite 1 over n times n plus 1 into this, you're gonna see a lot of things. Oops, just 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus and then plus 1 over n minus 1 over minus 1. Okay. So realizing that if we apply this into this, the component inside of this bracket, so you see this is what we have. And do you realize that starting from here, you're gonna have so many cancellations. So except the head and tail are the only two survivors. So we're gonna have 9 times 1 minus 1 over n plus 1. And it turns out you can simplify this. It's going to be coming into n over n plus 1. So hence it's 9n over n plus 1. So that is our nth partial sum. So we claim that if a series converges, that is the limit of the nth partial sum exists. So in this problem here, 9n over n plus 1. So do you realize that this limit, it exists and equals 9. So yeah, mission complete. That's how to handle this problem. Okay, cool. All right, so hope you enjoy this video, and yeah, happy learning.